service is still in initial stages, how can India strategize the business opportunities in GaaS so as to garner considerable share of global market in this domain? So I'll ask Mr. Noel to start it.
Okay. First, thank you everyone, and thank you for giving me this opportunity to be on the DAI today. Ground segment as a service is definitely something which is mandatory today due to the proliferation of LEO satellites. The many companies like KSAT, for example, or others are already known for quite some time, providing such contact, I'm saying contact to the satellites, to the spacecrafts. And we have been discussing also the opportunities with Avantel and some other potential partners here in India, because we are not as Safran Data Systems, and we don't want to be a ground segment as a service operator. But we are providing quite a lot of equipment for these kind of applications, and thanks to KSAT also. So the we have some opportunities. I mean, definitely there are some regulatory headaches, I would say, but I mean, it will move through. And there's a big potential for, I believe, partnership between companies which are in India, who have different locations where they could put antennas in India, and people who are renowned into that domain internationally. I mean, to have a better coverage. Again, I mean, it needs to be clarified from all the frequency which are allowed, they are able to transmit or not. But it's definitely a work in progress, and it's really looking promising.
Thank you. So would anyone like to add? It's open. Yeah. Yes, Siddharth.
Thank you so much, Kriti ma'am. And as you rightly said, so especially GSaaS in the country, this panel over here is one of the ones who are actually initiating the entire trend towards the right direction in terms of privatization. You have the policymakers who are working with the industry and making things happen for us to ensure that the policies are not pulling us back. They're in fact getting more and more businesses into the country and going to be the future. And GSaaS itself, it's not just about providing the services. It is the complete, you need an end-to-end solution. So you have Safran, who is actually providing the entire ground station systems. And then you have the world leaders in GSaaS services like KSAT, who provide just the services part across the globe, and they're the biggest. So, and then you have companies like me and Dhruva Space within the country who have received this authorization and are trying to take things forward. And good news is all four of us are collaborating with each other, and only through collaboration can we take this and make it leaps and bounds and make it a success. So that's my takeaway from this.
Thank you, Siddharth. So my question is for Adrian. So KSAT is planning to establish a GaaS in India. So how will your business model help in the growth of Indian space economy? And the second question, is it a threat to my Indian representatives? So please.
Thank you. Yes, first off, I agree very well with what Noel said. You said we've been working very closely with Safran for many years, as well as the things Siddharth said. Space is a vacuum, but space industry is not. We have to collaborate and have partnerships on a global scale. The main concept with a ground station as a service is flexibility and agility. We want to enable services to companies so they don't have to invest millions in setting up their own ground station network. And the best way to do this is with partnerships. Yesterday I had the honor of being in the embassy event, and they asked us what's the strategy of Kongsberg in India, And I made it very clear that our strategy is not to build in India, but rather build with India and together with India. We have been in India for 25 years, and that's only through partnerships. We have not done operations here ourselves. We only do it through Indian entities. And as of today, we do have antennas in India, which is solely operated through Indian entities as well. So for KSAT to come into India, we could provide a different ways of boosting the global space economy for India and the position. The first thing is that we can provide a short timeline for Indian startups to get into the space industry by utilizing our ground network. So they can focus on the value proposition for them and for the Indian governments and the Indian private companies, such as the payload and the mission services they have. By utilizing our ground network, they can also combine it with the Indian ground network, so we could provide the service globally to all of them. We have already done the infrastructure, so we're here to do this as a service. And this week I had many good meetings with many good friends here in India, and all of the topics of each and every meeting is only partnerships, not KSAT as a sole operator of the ground stations in India. KSAT will never set up their own antenna at their own land in India. We will only do it through global, local partners and local collaboration. So the value goes back into the Indian ecosystem.
Thank you. So, Mr. Noel, so do you have any plans for co-development and co-production of some of your recent technologies with Indian space startups?
So we have started to manufacture and to co-design some equipment, and while there's without any secret, I mean, there's a big tender in India going on, and we hope that we are teaming with the right people to win it.
Great. So seeing the present scenario, Mr. Keyur, so how many GaaS operators can be authorized in India? So 5, 10, 15, 20, so that the space ecosystem as well as the long-term profit margins are ensured. So can you throw some light? What is your take?
I think the number could even be 100 plus, and I'll give a sound commercial reason to that. Ground station as a service predominantly is a model preferred because the capex is just too high for a single satellite operator to absorb when we are trying to establish stations around the world. And like I think the spirit has been, one is make in India and another is make with India. As a market we are opening up, we are giving that home ground advantage to the companies like Dhruva Space and others which are trying to grow in the territory where we can engage and build on these models within India. So to ease access to the ground segment, it is important that more and more enterprises can be encouraged to take that up as an activity. Today, let's take an example of some sites which are highly preferred due to orbital configurations of the systems. We see there being antenna farms, many antennas in singular places. Technologically, that diversity of having those antennas maybe even 100 kilometers apart or 350 kilometers apart could mean a lot, especially to operators who are operating with India or adjacent regions like Southeast Asia and the Middle East as one of the probable advantages, as probable one of the commercial customers. So the more people continue establishing antennas in India, I don't see there being a very short-term or a mid-term implication of the market getting oversaturated or there being a commercial disadvantage to anyone. But of course, having said that, with each country, there are concerns over data security, operational integrity, and a lot more, because today commercial space is not just commercial space anymore because the services are always diverse in nature. Constellation could be served for military or civilian use cases where ground segment becomes a critical point of access. So we also need to solve for those challenges, and maybe those challenges might define the number slightly better than the commercial or the policy consideration alone.
Okay, thank you so much. So Adrian, would you like to add on this anything? Throw some light. So how many GaaS operators can be authorized in India? So we are just starting with 3 or 4 operators we already have authorized. So how big this number should be, or we should limit it?
I think, as you said, there's not really a limit. the government of India has been doing a fantastic job in liberalizing space ever since the initiative. And we could see the growth that this has had in the market of India and the space economy and your position out in the global space industry. So I think there shouldn't necessarily be regulations of how many operators you can have. I think an open and liberalized way of approaching this is healthy for the Indian ecosystem. And I think you will see more partnerships as opposed to competitors by going for this market, because space is a market where everybody cooperates. And this is what we see in other countries as well.
Thank you. So in-orbit relay, the inter-satellite link, and all these new technologies are coming up. So satellites won't rely on a ground station. Like, they might not need so many GaaS operators. They can like relay the information and get it downlinked at their own the ground station at their own country, or they can own their own ground station also. So this will evade the licensing and regulatory framework of foreign soil. So is this a threat, or this has no effect to the GaaS business? So, Siddharth?
So I would say, I don't know the exact answer to that, but there are limitations to inter-satellite communications. But even if there is processing capability in space itself, I would still say that it is limited, and it might be the kind of resources that you have on space would be used for specific applications only, but not for the entire processing of the humongous data that they're actually capturing. One of the key important thing in GSaaS is there are a lot of EO satellites and other satellites which capture lots of images. And the amount of data that they can capture is also restricted by various conditions, as the kind of orbit it is in, as well as the weather conditions at that given point in time, and the life of the satellite itself to get your ROI. So with the limited time in space, it wants to capture as much data as it can, and it only has limited space out there in its transponder or the hardware capability that you have, because weight is also a big constraint when launching the satellites. So it is very important for these satellites to dump the data as soon as possible. And that is the reason why they cannot wait for, let's say, 8 hours to again dump the data. So it has to be done very, very quickly, and hence you need various ground stations at various locations across the globe to ensure that they're not unable to capture the data because their disks are full. So I feel that even if there's intercommunication, that is much more for strategic in nature rather than and TT&C operations. Yes, there'll be a little bit reduction in the revenue, but in the data reception, I don't see much of a difference going forward as well.
Thank you, Siddharth. So, Mr. Noel, would you like to add anything?
Yeah, I mean, it's this is true that there will be some changes. We are providing optical ground stations also for higher bandwidth, and but there are some limitations. I mean, due to weather conditions also. There are different use cases where the inter-satellite link will be beneficial. Okay, but on some others, as mentioned by Siddharth, it's important to have the image as soon as possible. And I mean, it's for tactical purpose. And this is, by the way, a big thing in the forces currently through the different issues that we have seen recently. And to keep things short, let's say, there will be decent business for the ground segment as a service as it is today. Again, that will change, but we have some comfort, let's say, using SNX, for example, and K-band when it's required. But if you are in some areas of the globe, I mean, K-band is challenging. You don't have a good reception, so that's the reason also you have different type of modulations in order to not lose any data, but I mean then you have some issues. So it's a combination of both. I mean, in the ground stations, but I mean, Adrian can talk better about that than myself. But you have also the typical ground stations where you have everything at the ground stations, and you have others which are fully virtualized, so that everything is going to the cloud. And I mean, it's from an economical point of view, it's much more efficient than ISL.
Thank you. So, Adrian, your take on that?
Yeah, most of the previous attempts in interrelay concept has faced one challenge, and the challenge is that they don't have access to the ground stations. Because even though you operate interrelay connection in S-band from satellite to satellite, you still need to be able to downlink the data. Now, the true value proposition of space-to-space communication and relay communication is that you will have S-band transfer with Earth observation services. You will have low latency. But in order to get that, in order to get the data within the minutes that you wanted, you would still need the network of ground stations. So I think we will see more of interrelay businesses and coming up, but not for nominal TT&C operations, but more for actually Earth observation services. And they will not be a competitor to the ground station segment, but rather an enabler for continued development and expanding of ground stations.
Yeah, thank you, Adrian. So, Keyur, can you summarize and add your remarks to it?
So I'll actually put a satellite operator's perspective to this, right? In space, the challenge for ISL is the same as the challenge of ground station networks on Earth. We need plenty of them to be able to do ISL efficiently, and we need them in proximity. And today, what we're looking at as one of the biggest markets, apart from legacy constellation operators, is satellite operators who are operating maybe 5 to 25 satellites, where this concept of ISL may not really become a primary source of reliance, but of course it has its advantages. Like one of the things like Siddharth said on decision making, at the end of the day it has to come back to ground for decision making, processing, and that intelligence to go in for primarily EO and other missions. For when we look at it, slightly expanding the definition of ground station also to gateways, while it is very efficient for a communication constellation to have ISL as a means to relay network data through different places, but at the end of the day, it has to come to the gateway for doing that network management and giving access to the backbone. So I think it will actually play a complementary role, because the more efficient ISL systems become, there will be more incentive to establish larger constellations, to establish satellites in orbit, which can actually give decision-making intelligence and improve latency on the ground faster. And a good market means more demand, and more demand means more satellites, is how I would look at it in the long term. So it is certainly an enabler also in one way.
Thank you, Keyur. Thank you so much. So what are your predictions for the next disruptive innovation in ground station services? Mr. Adrian?
I think we're already on the way. I think one is the relay, but as again, I don't think it's a competitor or a disruptive existing business and industry, but rather an enabler. The other one is edge computing and optimizing the AI data handling of the actual data in order to process data faster. And the other thing is like Noel has mentioned with KA bands and tri-bands and dual bands, there's different ways to build antennas and set up the S-band, X-band, and frequencies. So I think we will see innovation on that. But I think the main possibilities of disruption would be within edge computing and the processing actually and the handling of the data.
So you'd like to add anything? So your prediction for a disruptive technology innovation.
Yeah. I mean, there's a lot of research done and also deployment for the optical ground stations, which are integrated into, in fact, ground segment as a service for higher bandwidth. But today, I mean, it's and it's physical. So we have some challenges with the optical ground station. There are some also regulation for the uplink, I mean for what we call the feeder link, which is the uplink. So the traditional ground stations are still very useful, and for some time, I would say.
Okay, so to the new entrants, so what are the technical challenges that you're facing? Any technical challenges that you would like to add?
For the existing ground stations, so one is we're relying on our good partners to do some knowledge transfer and hold our hands in terms of the initial integrations and the concepts, the ifs and buts, because unless and until you actually handle real-time scheduling and the redundancy that you need to have to ensure, because that is what satellite operators would actually expect, and it's going to be critical as well. So what are those challenges are the ones which we are not aware of, to be honest, and that is where we are expecting our partners to assist us and guide us in that manner. Just to add to the previous question as well, I think in the ground stations, it is still, I think, premature, but companies like Safran and companies in Australia are already working on these things, where it's the ground station right now is only being able to track one satellite at a time. But I think there are ground stations which are actually coming up, which are much more phased array, where at any given instance, they can even actually try to communicate with 10 satellites at a given point in time. So it's an enhancement of the ground stations to the next level of ground stations, which are much more capable. Maybe when that happens, you might see, rather than having one ground station, you might have a much more expensive ground station which will take lesser real estate, but can handle number of passes at a given instance. So I think that's a good disruption to have. But in terms of challenges, I'll have to have a really good partner to in the long term and a long-term relationship to guide us through the initial phase.
Okay, thank you. And Keyur?
I'll put it into very small parts. So one is when we are trying to establish ground stations ourselves, I think there is a lot of chaos around how spectrum coordination would work, especially for Ka band, which is one of the ideal bands to choose for downlinking data. So you end up choosing a location which maybe does not have existing infrastructure of relaying the data from the ground station to the data processing center. So that is one of the biggest challenges that we look at, like apart from the real estate cost, etc. Now, when talking about ground station as a service, there is a lot more that it's not a key challenge today, but it will become a key challenge in some time, as there is more and more reliance on EO-based space data for rapid decision making, where if data processing and decision making could be integrated in some form at the ground station sites which are being used in other territories, that could really be an enabler. And we are seeing some offerings come around data centers being integrated, but that of course comes with a lot of regulatory challenges on how data can be handled locally at stations outside someone's jurisdiction. So those are perhaps the two immediate challenges that are there to solve. And I think I would just like to re-echo what Siddharth said. Today, if one has to look at ground station as a service in some key locations of interest, it's really important to now optimize how can leaner infrastructure handle much more of operations. So that's
Yeah, thank you, Keyur. And any regulatory challenge that you're facing in India?
I think we are just waiting for the DOT norms and guidelines to come out on how spectrum will be assigned and what would be the licensing regime for the ground station. The TRI recommendations do look very, very positive. And I think as and when more guidelines come out on how licensing, spectrum assignment, and maybe if there is any associated equipment testing and verification mechanism or NOCC related obligations, if they're replaced with something else, or if they continue to exist, these are points which we await on very eagerly to be able to know more, whether there are more challenges coming or not.
Thank you, Keyur. So, Adrian, can you discuss your approach to frequency licensing and regulatory compliances across different jurisdictions where you have your antennas?
Yeah, as I mentioned earlier, we've been operating for almost 60 years, and we have almost 400 antennas across 30 plus locations around the world. So we have been interacting with regulatory bodies all over the world, and we do it on a daily basis. KSAT has a very big team that works solely on the integration towards governments and entities that does regulated processes. For all our clients, through the ground station as a service, we handle all the regulative processes towards their missions, so our clients don't do anything. And the way we do that is, first off, having a good partnership and cooperation with the government programs and the government entities that does handle the regulations. And we can see this throughout the years, that there's a standardization going on where more and more countries are going together and they have the same processes, the same costs, in order to capture the market and bring more clients to actually utilize the antennas in their country. Because in the end, that will create more business for the local countries. So the way we interact is by partnerships and meetings, and meeting the governments and having good relationships with the governments and providing our input. And we're very lucky to be in a position where we've been doing this for a long time, so a lot of governments approach us and other entities around the world that works in the same industry to provide inputs on best practices. And I've had a lot of interactions with India the past year regarding this, and I can see that the government is doing a really good job in liberalizing space and opening the regulations and the processes moving forward. And as my friend said there, we're still looking forward to the final final conclusions. But I'm sure that India, and it seems like India is doing the right and going the right direction. So whatever way we could support this and continue our interactions in India is most welcome.
Thank you, Adrian. So what are your strategies for supporting new technologies like optical downlinks, quantum encryption, or AI-driven automation? So, Mr. Noel.
So I already addressed optical ground stations. I mean, so I won't go back to that. There are different standards, but I mean, it's not the point. CCSDS or SDA that needs to be addressed. I mean, to be fully compatible with different satellites, and there are not that many who have optical downlink, at least. Not speaking about uplink, which is even more rare. As you, I mean, we were all talking about the big amount of data. So definitely, when you go to processing of the either EO satellites or Earth observation satellites, whatever they are, optical payload or radar payload, it's a big challenge. Also, the synchronization of the data is another challenge. But there's a requirement to use artificial intelligence. And well, there are different solutions already which are implemented by the image processor, who are directly linked to the payload manufacturer in order to have all the tricks, let's say, for the image processing. And it's there's another thing also is all the safety, the cybersecurity attached to providing these processed data. When it's raw data, it's critical because they can be jammed. I mean, not jammed, but corrupted. And but when you want to transfer real data, real information, because it's processing data to get the real information, cybersecurity is becoming an issue. It's not only on the data from the payload, but it's also on the data for the telecommand and control of the satellites, of course, because I mean, it's if you don't send the right information to the satellites, you can be generating big problems.
Right. So he pointed out the challenge of cybersecurity. So how are you, Keyur, addressing it in your upcoming ground station? What are the precautions, or what are the implementations that you are taking care so that the cybersecurity breach is not happening? So can you share?
I think there's one fundamental principle that we use to design the entire operations or the network that is behind access of a potential customer, which is there should be no unencrypted data there at the ground station. So technically speaking, I think beyond error correction, we wouldn't allow handling of the data at all at the ground station itself, because it also comes not just with security, but a lot of other concerns, because each country has different laws pertaining to data privacy and protection. And if it goes into the domain of personal data, say for example, someone's IoT device data or image of some restricted territory which belongs to an individual person, depending on the country that comes from, the operator comes from, there could be a lot of implications. So that is the starting point. But now we are also looking at trends where people are looking at more secure, quantum secure communications by doing random number generation to see if each of the passes could have some sort of unique method to ensure encryption of the data involved. The next step to that, of course, is looking at how access is done. I think remote access is one of the things that has been a continuous discussion and concern in India. Honestly, we are looking at whatever are the global best practices that are being implemented, which is largely making sure that you do not allow any access into your network without having adequate security layers in the interim, so that both the ground vulnerabilities of the ground station operator do not transfer to the satellite operators, MCC, and vice versa. So with these basic principles, we've been structuring and strategizing data security and cybersecurity for the missions.
Siddhartha, what would you like to add regarding the cybersecurity aspect?
I think I'll actually echo with what Keyur just mentioned. The premise that ground station as a service, it's just a service from an infrastructure standpoint. Back in the day, the GSaaS operators were hosting the data at that specific location as well. But with the advancement of technologies, you are using this infrastructure as just a pass-through, and directly being able to connect to a private cloud which is satellite operators' cloud or data stores, and directly sending the data to that location. And we are only keeping specific records, which are what is the satellite, sub records which are required for audit purposes, but nothing more than that. But like Keyur just mentioned, I'll re-echo that any data which is coming in usually is encrypted and can only be decrypted by the end customer themselves, not us. So unless, it's secure.
Okay, thank you. So we would like to have 2 or 3 questions from the audience. Anyone would like to ask? Yeah, sure, sir.
Thank you to the panel for the insights on a new and upcoming area, the GSaaS in India in particular. I have 2, 3 questions, quick ones. The first one is to Mr. Sheils, coming from KSAT. Do you think an antenna farm kind of a concept would work in India? Or do you see more number of players with a more distributed single stations or maybe a couple of stations kind of a format developing?
Yeah, I think in India you have the opportunity to have many farms, not single units, and the reason for that is because there's a very high investment cost when you have to set it up. We've been discussing security, and one of the things is cybersecurity, but one of the things is actually physical security. You also have to ensure physical security of the infrastructure on the site. India has many very good places, high elevated, dry places that could support a range of different bands, and also has the openness of the green fields that you could actually have several antennas.
Right.
So I definitely think that we will see more antenna farms, and I think it's also the right direction to go based on CAPEX, but also on resources and what capabilities that will actually bring.
That's an excellent point, thank you. In terms of the finances involved and the logistical, coherence and sustainability, having antenna farms may be the way to go. Is that really going to work? This is for the panel as a whole. If you have multiple different companies, right, joining hands to be part of one antenna farm to be run by, one agency, do you think that's a usable, a practicable model?
Yeah, I think so. That is one of the that is one of the solutions to look forward to. In fact, there have been coexistent methods which have already been identified. For example, today, if someone wants to set up an antenna in a certain territory, one of the first preferences is to look at a existing antenna farm and go for a hosting solution from the person who is really manning the farm, etc. So that actually serves two purposes. One is when there's a farm with multiple operators or multiple antenna owners, it brings down the entry cost for each one of them. And with that option open to continue hosting more antennas, we're extending that ease of access to the ground segment as a market to more and more players, where diversity of return from the capex investment for someone is coming not just from providing ground station as a service, but also providing hosting as a service. So it is a good de-risking and market access mechanism for whoever is the lead player or the mover who is making that investment in the infrastructure which is needed to sustain a ground station antenna there.
Right, and another point that comes to mind is each of the ground stations is going to require a certain amount of sanitation to be away from urban areas and the interference-related issues. So probably more secluded places which are out of the thing, and those may be few. So that, I think, also makes kind of sense to what the panel is talking about. A question about the security part. While we talk about the encryption and cybersecurity of ground stations, is there any kind of a dialogue or a conversation between the satellite manufacturers and the ground station manufacturers on having compatibility in what you're going to do? Do the satellites have to be designed in a way that's going to lend itself to greater security protocols, better security protocols along with the ground station? So is there coincidence there?
Yes, I can answer that. One of the biggest shifts in ground station history is multi-mission ground station antennas. Before you would have antennas that were specifically created for a specific mission, but now we have multi-mission antennas that companies all over the world can use. If you're compatible to one antenna, you're compatible to all the 200 antennas around the globe. The only way to be compatible is that you actually use compatible hardware. So when we're looking into the antenna configuration of the satellites, it has to be configured and has to use the frequency and the mode, specifically the modes type that is compatible to the antennas that we built. And this is something we see a lot with the satellite operators, is that they actually approach us and ask us, how should we build our satellites in order to stay compatible with what's happening in the ground station segment. And most of our clients is also clients of other ground station service providers. If you're launching a satellite or a rocket, you want to ensure mission success. So you don't go with one ground station provider, you go with several. So you have coverage all over the globe. So it's kind of a unified approach where we have most of the antennas have the same capabilities in terms of which compatible satellites they have.
Thank you.
Hi, I'm Sangeeta. My question would be to the panelists. When you operate GSaaS as a business model, what are the critical problems that you solve for your customers? And my second question would be, what are the key bottlenecks for satellite operators to get ground station access? Thank you.
This is for me as well. So when it comes to the business model and what we're basically solving for the clients is, as a startup company, you might have built a very cool and very good camera. And you have promised someone that you will provide them with their photos, etc. That's your value proposition. That's what you're making value on. That's the payload of your satellites. You can invest in that, and you have the technology and the resource and the competency to build that. But if you're going to start focusing on building your own ground stations all over the world in order to deliver this data and finalize this mission, you will be looking at incredible high capex costs. We have been investing steadily in an average of 30 to 40 antennas per year. That's the benchmark that we have in order to actually enable more and more startups to get into the environment. We are traveling the world helping university students getting access to their satellites because we want to increase the economy in the space industry. So the main value that we provide is actually very cost saving and also the timeline. Someone can come up to us and say, we're going to launch a satellite in 3 months, can you help us? Most likely we can. But if we didn't have those ground stations, they would be looking at 2 years before they could launch their satellites.
Hi, this is Vikas here, this side, right side. So actually just wanted to understand what is the applicability of LEO telecommunication satellites for ground station as a service, and what are the potential market opportunity for this?
So everything we do is LEO, and we operate in the low Earth observation services. That's mainly where we see the need of a ground network as it is. If you're operating with geo antennas, then you want to triangulate to specific located antennas, which are constantly pinging to the satellites. So we don't operate in that industry at all. Most of the geo satellites are operated and owned by telecommunication companies that have their own teleports, which you do in India already. So most of the geostationary satellites in India are supported by Indian government or Indian private companies. For the low Earth observation services, I think that's where it will increase the most. Earth observation services is one of the highest growth industries within space. Everything from maritime to surveillance to gas leaks of oil rigs and gas pipes to maritime monitoring of your coastline. So most of the satellites that we see being built are within LEO orbits and within the Earth observation services. Yes, so for Starlink and Kuiper, they're configured in a way that they have used their own antennas. Theoretically, yes, you could utilize a ground network station to communicate with Starlink and the Kepler and those. But as of now, they utilize their own antennas. That way you see the Starlink antennas on people's houses all over the world now. So they use their own setup when it comes to that.
I mean, the antenna actually supports dual or tri-band S, X, and Ka. So the satellite has having the payload transponder, those bands, and you actually have the hub electronics which are connected to that ground station to receive that data and then do the communication net wherever you would want to send it to, and have a constellation which will actually have you with latency as well. Not latency, but if that you have a pass-through time of around maybe 12 minutes. 10 to 13 minutes. So once 13 minutes pass, from a communication standpoint, you don't want your call to be disconnected. So you want to have another LEO constellation coming in, then that taking over to the other one. So you need to have hub electronics is very important in that aspect, or the use case which you just mentioned.
Hi, this is Vinay here. This is a question for the panel. Is there a way that ground stations can get smarter in the next versions of it? You mentioned about 40 ground stations being installed per year. The satellites will start growing more and more and sense a lot of data. Is there a way that you guys can do something downstream to smartly process the data that comes down?
So yeah, most of the antennas we buy is from that mister. So I'll actually give the word first to him.
So, as we were mentioning earlier, definitely there are some evolutions, and the beam steering antennas are coming. From an industrial point of view, it's costly today from maintenance and so forth. But I believe in 2 to 3 years, we will see more and more antennas with beamforming. They are most of the time specialized to one frequency, but this is something which is complementary, let's say, of what is existing today, and which brings the benefit of addressing several satellites at the same time. The one thing I wanted to mention also, we have been speaking about satellite, but I mean ground segment as a service is also used for launch vehicle. And now there are more and more launch vehicles, and definitely people who are building launch vehicle, they have to collect the data during the flight for many reasons, and they don't want to deal with ground stations, and it's something. It's a tool for them, and they want to concentrate on the launch vehicle. But it's really a growing business for us, Ms. Bart.
just to add on, I think making ground stations smarter from the data side, more than a technical, I think it's a legal limitation today, because if I'm an Indian satellite operator, I can do anything with a ground station in India as long as there are some basic security protocols which are observed. But the moment we try to use ground stations outside India, and not just for us, it's the same for all countries and all jurisdictions, there's an extent to which data can be handled at a third party's premises. So there's very little scope with that legal stipulation and limitation unless there are more innovations on the cyber security side. And innovations on security aspects is, of course, something very tricky and very long-term to solve.
Yeah. Good afternoon. This is Wing Commander Senthil. I just wanted to add on the same question since you already brought out. This question is actually regarding ground station as a service. I think right now, what is the key challenge? I mean, like what you brought out, some of the legal aspects of privacy, security concerns for the for example, the infrastructure as such, which can be offered as a service, because already ground segment is there, but which key element in that is the infrastructure itself. So how do we want to give privacy protection for the same in terms of, say, for example, some hybrid architecture which you're looking at or something like that? Is there any solutions that that's already available in the market, which we can utilize?
I think one of the main questions was how do we ensure privacy and security on antennas? And the way we operate from KSAT side is everything that's been mentioned earlier in terms of cybersecurity. We have one of the biggest departments in KSAT is cybersecurity and physical security. And the way that we ensure security on antennas in specifically sensitive missions is that we provide dedicated own antennas to our clients, so no one else has access. An antenna is basically us installing our racks. When we install a rack in antenna, we can connect it to our network. In that process, during that process, we have a lot of leverage and processes that we can implement in order to maintain and ensure cybersecurity. So KSAT and most of the ground station as a service provider should always aim to never really touch the data unless specifically requested. So if a satellite operator goes through the network of a ground station service provider, the only real connection that we have is the actual command to the satellites. But even though the command itself is not open for us, it's still encrypted. But we can see a command go through our system, but we don't have any insights in what's going on. After that, everything is handled in encrypted ways. The data is transferred directly to the site of location of your choosing. So I think that's how we are ensuring privacy, and I think right now it's been working very well, and we don't have any challenges on this so far. But most of the innovation here is not on the ground station side, it's actually on the networking side and the link side that is set up to the antennas.
We were actually asked one question by the DOT and InSpace as well. Since it's just infrastructure and just GSaaS, what happens if some of our neighboring countries leverage our infrastructure for some other things? So the answer to that is it's not open. So before they actually consume our infrastructure, they have to go through a registration process, and DOT and InSpace have to approve it and go through the IT coordination. They should have the right IT coordination as well. So we have the right to reject and approve which satellite constellations that we would like to support or not in terms of security or Indian security aspect.
So we can take one last question.
Hi, I'm Nitish from InSpace. My question is to KSAT. What kind of value addition KSAT, like companies like KSAT, would bring to India if they want to establish ground station fleet in the India?
So, as I mentioned earlier, we will never come here, purchase land, and establish our own ground stations. What we will do and what we would like to do is enable Indian companies to do that. And the way we do it is the same way we've done all over the world. Local partnerships, different business model, different revenue models that are mutual beneficial. When we operate in a different country, we build antennas and we build a farm as was requested earlier. This farm will have high maintenance resources with a lot of local employees securing the facility, maintaining the facility through local partnerships. Additionally, the model of our network is set up in a way that a local partner, we would be allowed to use this antenna for our clients for general LEO support, but the local partner would also be able to utilize our network for its local clients. And in that way, we can enable ground station service providers that are in the startup phase or upcoming phase to actually utilize a lot larger network than what they would most likely have. And I think that's the main value we would provide to local ground station service providers.
So I thank my panelists for such an engaging insight into ground station as a service, as well as the audience who kept themselves wake up even after having that delicious lunch. So ground station as a service is emerging, and after space reforms, this has also caught attention in India, with the Indian space policy bringing out guidelines clearly for ground station as a service, as well as try recommendations that came out recently, and DOT working for the regulatory framework. We are sure in the coming months we'll be having a lot of clarity on how GaaS can be operationalized in India. At present, ground station for self-use is allowed, and that is coming up, and our operators are using their own ground stations to support their satellites. And importing of importing of ground station equipment from experienced people like Safran and all are also getting cleared by the regulatory departments, and they are having clear guidelines for the same. And like space is for all, similarly controlling the satellites can be done while having a collaboration between the different stakeholders and the different like the KSAT, having Safran, having an Indian partners. So this collaboration will really help this segment also grow and contribute to the Indian space economy. So this with this, I would like to thank all my and the audience, and thank you so much.
Thank you so much to all our panelists for that truly insightful and meaningful conversation. As a token of gratitude and appreciation, we now present our mementos to our eminent panelists. So I request our moderator, Mr. Kriti Khatri, to please present the mementos to our panelists, to Mr. Keyur Gandhi, Mr. Noel Ballot, to Adrian Sheils, and to Mr. Siddharth Abburi. So may I now request our DS Govindarajan, board member of the SIA-INDIA, please present the memento to our session moderator, Mr. Kriti Khatri, ma'am. And please put forward for the good photograph, please. Thank you so much, everyone. And now we'll take a short networking tea break. After that, we resume again in this hall for the next session, that is a Beyond Earth, Building the Outer Space Economy. Thank you.